Imagine a thief who enters a house by following a tour guide, but gets trapped inside because he never learned how to unlock the front door himself. That is exactly what happened to your brain the last time you studied a math solution. You watched the walkthrough, your brain effortlessly followed the tutor's steps, it felt like learning, but it was actually a biological illusion. Your mind tracked someone else's cognitive path and mistook passive recognition for actual ability. You didn't learn the route, you just watched someone else drive. And the exact millisecond the exam stripped away that guidance, your brain panicked, hit a wall, and completely froze. In exactly 3 minutes, I am going to show you how to exploit a learning blueprint used by Nobel Prize-winning physicist Richard Feynman to force your brain to build unshakable understanding. It is a method that transforms you from a passive spectator into a structural builder. But if you try to use it right now, your biology will completely reject it. Here is the hidden trap you are walking into. Think about last week. You watched a video explaining how to solve a quadratic equation. The instructor worked through the example step by step. It made perfect sense. You even paused it, rewatched a section, took notes. You felt like you got it. Then you closed the video, opened a practice problem, and stared at the page like you'd never seen math before in your life. The numbers were different, the setup looked unfamiliar, and that confident feeling you had 5 minutes ago, gone. You think that's a memory problem. It's not. It's a recognition trap called the illusion of fluency. When you watch someone else solve a problem, your brain tracks their logic and mistakes that for your own understanding. It's like watching someone do a backflip and thinking your body now knows how to do one. You observed the process, you didn't encode the process, and your brain can't tell the difference until it's too late. But it gets worse. Every time you reread the same chapter or rewatch the same explanation, you're strengthening the wrong type of memory. You're building recognition strength, the ability to say, I've seen this before, but not retrieval strength, the ability to reconstruct the solution from nothing. Your brain is a prediction machine. It sees the formula on the page and says, oh, I know what this is, and that flash of familiarity convinces you that you've learned it. But familiarity is not understanding. It's a shortcut, and shortcuts don't show up on the test. So what do? You study harder, you go through more examples, you highlight your notes in 3 different colors. You tell yourself, if I just see enough problems, eventually it'll click. But repetition without retrieval is like lifting someone else's weights and expecting your muscles to grow. The effort is happening outside your brain. You're not building cognitive strength, you're just watching someone else build theirs. Here's the belief you need to destroy right now. The idea that understanding math means being able to follow someone else's explanation. That's not understanding, that's spectatorship. Real understanding is what happens when you can take a concept and teach it to someone who knows nothing, when you can explain it so simply, so clearly that a 12-year-old could rebuild the logic from scratch. That's the Feynman technique, and it works because it forces your brain to do the one thing that actually creates long-term memory: retrieval under constraint. You keep thinking, I get it when I see the solution, I just can't do it on my own. I understand the concept, I just mess up on the application. Maybe I'm just not a math person. If I could just memorize the steps, I'd be fine. But memorizing steps is the problem. Math isn't a sequence to memorize, it's a structure to internalize. And the only way to internalize a structure is to force your brain to reconstruct it without looking. Here's the shift. After you learn a new concept, whether it's derivatives, logarithms, probability, anything, close the book, open a blank page, and explain the concept out loud as if you're teaching it to someone who's never seen it before. No jargon, no formulas you haven't defined. If you say derivative, you have to explain what a derivative actually represents, not just how to calculate one. Every time you get stuck, every time you can't explain something in simple terms, that's not a failure. That's your brain showing you exactly where the gap in your understanding is. You go back to the source, fill that specific gap, then try again. You repeat this until you can walk someone from zero to solve a problem using only your explanation. This is retrieval practice under the constraint of simplicity. You're not testing whether you remember the steps, you're testing whether you understand the logic deeply enough to rebuild it from nothing. And that act of rebuilding, that struggle to find the words, to connect the pieces, to explain why the method works and not just how, that is what creates the neural encoding that lasts. You're not strengthening recognition, you're strengthening reconstruction, and reconstruction is the only skill that transfers to new problems. Once your brain learns that understanding means I can explain this, not I've seen this before, math stops feeling like memorization. It starts feeling like a language you actually speak. You started this video thinking you needed to study more. What you actually needed was to stop consuming explanations and start producing them. You're not bad at math. You've just been using a learning method that trains recognition instead of understanding. That difference between watching someone solve it and forcing yourself to teach it is the only study technique that's ever actually worked. What happens when you apply this to every concept you learn until your default mode isn't reread the notes but explain it from scratch? That's when math doesn't just get easier, it becomes inevitable.